So this is going to be the fourth module in our CrowdStrike security series. We have completed CrowdStrike Certified Falcon Admin, CrowdStrike Certified Falcon Responder, CrowdStrike Certified Threat Hunting, and this is the fourth module, which is CrowdStrike Certified SIEM Engineer. So in this module, we are primarily focusing on log monitoring capability of CrowdStrike, security log monitoring capability. We will also try and understand how Falcon Protect or Falcon Endpoint Detection and Response is different from SIEM Engineer course, or what are the different capabilities between Falcon Protect and this is your Falcon Insight. So you want to understand those capability difference also. However, since some of the participants are pretty new to this domain, they have not worked with SIEM and SOAR solution in the past. They have not worked with any security log monitoring solution in the past. I've decided to reserve or dedicate today's session to bring everyone on the same page before we get started with CrowdStrike SIEM Engineer module. So this session is dedicated on SIEM and SOAR fundamentals. I will explain every minute aspect of SIEM and SOAR from fundamental perspective, so that when we start with CrowdStrike NG-SIEM, Next Generation SIEM module, you all will be on the same page. You all will understand the concepts. As I promised to everyone whosoever spoke with me before signing up for this session, that I will bring everyone on the same page. So some participants have prior experience of working with SIEM and SOAR solution. You probably have worked with solutions such as ArcSight, Alert Logic, Logarithm, Splunk, QRadar, Microsoft Sentinel. But then there are some people who have not worked with any solution in the past, or probably they are new to cybersecurity, and this is going to be their first, experience of how we do things in cybersecurity. So we will start with the fundamentals part. Okay, so hope my screen is visible to everyone. So let's get started with the fundamentals part. Now I've written two terminologies here in the presentation, SIEM and SOAR. Now, first of all, let's look at the right pronunciation. Some pronounce it SIEM, some pronounce it SIM, some pronounce it SIEM. I've been to multiple countries. I've been dealing with these solutions for the last 12, 15 years, and I've seen people pronouncing it, in different versions. Now, all of the versions are correct. There is nothing right and wrong. You can call it SIM, you can call it SIEM, you can call it SIEM, as long as you understand what the other person is saying. Okay, and this is known as SOAR. There is no second pronunciation here. We don't call it SOAR, SOUR, it's SOAR. So remember, it's SIEM, SIM, SIEM, and SOAR. Now, what are these tools? Why do we need to use these tools? What value proposition they bring on the table? How to design and architect these solutions? How to configure them? How to leverage the capability that it brings on the table, as effective as possible, is what we are going to discuss, in this session as well as in the subsequent sessions. So CrowdStrike SIEM Engineer and SIEM Analyst, they are going to be combined modules. I will cover them combined, and it will run. The session will run for at least 7 to 8 weeks from now, a minimum of 7 weeks, and it will run in continuity. There will not be any gap because we already have a gap of 3 weekends. So I can't afford to, have any other gap, because I have certain target, and within that target, I need to finish all the modules. After this, we will have 2 more modules. Probably there will be a third module also on prompt security. But then after this, we have cloud security and identity security that we need to cover. So let's get started with the fundamentals, or with the introduction of SIEM and SOAR. I call it SIEM. So this is what I pronounce, SIEM. So when I say SIEM, it means that I'm referring to SIEM or SIM. Let's get started. So what are we going to cover here? We are going to cover that why SIEM and SOAR matter in modern SOC. Now, what SOC stands for? SOC stands for Security Operations Center. It is a dedicated team whose job is to constantly look for anomalies, threat, incidents, adversaries, misconfigurations, indicators of compromise, indicators of attack. Remember these terminologies. In the world of cybersecurity, terminologies are very important. It may be a technical jargon for you at this moment, but these are the terminologies that you need to remember that I will keep on speaking and you will get familiar with these terminologies. So when it comes to modern SOC, we're not talking about a traditional SOC where you have a team looking at a bigger screen, you can call it dashboard, and looking for anything that is shown in red, amber, and then picking it up, trying to get into the details of what that specific information is, trying to investigate, triage, and remediate. That's what traditional SOCs do. We're talking about modern SOC. We're talking about a SOC that you will configure in the year 2026. That's what we're talking about. So what SIEM and SOAR solution contribute to modern SOC is what we're going to discuss. What SIEM is, its core architecture, how it looks like, what are the building blocks, what are the components that collectively make a SIEM solution, data ingestion method, how do we ingest data? When I say data, we're talking about logs. So how do we ingest logs into the solution? What are the different ingestion methods that are available? What is log parsing and normalization? Log storage and retention. After the logs are ingested, they are transformed into a certain format, a format that is common to that solution, to the SIEM solution, so that SIEM analysts, SIEM engineers, SIEM administrators, they can write security monitoring use cases, or they can write a query, and that query will run against the log, against the normalized or transformed log, and it will generate outcome. It will generate results. Those results are in the form of security incidents or detections. What is SIEM query language? We'll talk about detection and correlation techniques. You can see the color coding. This is an amber, so this is talking about SOAR solution. Common SIEM security monitoring use cases. What SOAR is, SIEM versus EDR, and common pricing model. So that's what we are going to look in the next an hour and a half or probably 2 hours. And trust me, after I'm done with this session, you all will be on the same page. If you already have experience with SIEM and SOAR solution, this session is going to help you organize, structure your knowledge, probably fill the gap if you have had any so far. So please make sure that you attend this session. You remain attentive throughout the session. I will give you an opportunity to ask questions. You can put your questions in the chat window also. I will take a pause, look at the questions from the chat, and I will respond to those questions also. If you have any questions, you can also raise your hand and wait until I call your name. Thank you. Okay, so let's talk about why do we need a SIEM and SOAR solution. So when it comes to cybersecurity, when it comes to security, information security, physical security, cloud security, we have different versions of security, right? It all started with physical security, then it transformed into information security, then it became cyber security, then it became cloud security. Today we talk about AI security. So it has evolved over a period of time. But throughout this journey, throughout this evolution that has happened in the last 25 to 30 years, one solution or one technology that remained common was SIEM. Because at the end of the day, any application that you are trying to protect, any data that you are trying to protect, any server that you are trying to protect, any device that you are trying to protect, you are basically analyzing the logs that are generated by that device solution application, and you try to identify if there is any anomaly in that log. If that log points towards any misconfiguration, if it points towards any indicator of compromise, if it points towards any deviation from standard or from day-to-day activities. That's what we primarily look at. So why it matters, why SIEM and SOAR solution matters? These solutions will basically help you to analyze large volume of logs. When I talk about an enterprise, I'm talking about an enterprise which is global, which has thousands of 10,000s of devices, desktops, laptop, servers, mobile devices, mobile phones, tablets, networking devices such as router, switches, network security devices, VPN, firewall, IDS, IPS. We're talking about a lot of devices and applications. And all of these devices, they are generating logs. When an action is performed on these devices, a log is generated. A log is an evidence of an action which is performed on the device or the activities which are happening across that device. So logs are getting generated. Now, who is analyzing those logs? Why do we need to analyze those logs? It is important to analyze those logs because those logs provide us visibility into something that is not usual, something which is a misconfiguration, something that can help us identify a threat even before it damages the device or your environment. So that is where we have alert fatigue. An enterprise is using multiple devices, and those devices are generating logs. And as a human, it is really difficult to analyze those logs all the time. So high daily alert volumes, but real threats and noise. Now, if there are thousands of logs that are getting generated, not all of them will point towards a misconfiguration or deviation or an adversary or a threat or an incident or some sort of compromise, some sort of attack. You will need to identify out of 1,000 which two logs are actually positive. They are true positive. They actually provide you some visibility. And rest of them are more of an information purpose. Rest of them are some common behaviors that must exhibit in the environment. So alert fatigue, that is where a SIEM solution will help you. A SIEM solution has the capability to analyze the logs effectively, identify the critical behaviors, identify the misconfigurations, identify the any deviation, any alert, any threat, or any incident which is there. So it will save a lot of time on part of your team members, and it will also result in productivity. That's why we need SIEM. The other benefit is slow manual process. When your team is identifying logs, it will take a lot of time. For example, if I navigate to logs from my system, so I opened event logs here. Now, these are the logs which are getting generated on my laptop while I'm using this laptop, while I'm opening applications, while I'm working with various windows, various applications, while I perform an activity on this laptop, it is generating logs. And if you look at these logs, look at the total number of logs that it has generated in the last 1 hour. These are the logs: 2,806 audit logs, 281 information, 12 warnings, and then 5 error logs are also there. So if I just click on these 5 error logs, it basically gives me some insights that what kind of errors are reported on my system. Now, these logs are generated in just 1 hour. If you look at the last 7 days of logs, we have thousands of log here. And there are thousands of systems in any enterprise. So would it be possible for a human to actually analyze them in near real time and then be able to analyze what is false positive, what is true positive? Now, these are another terminologies that you will come to know about while you deal with these solutions or while you deal with any cybersecurity solution, that they generate alerts, they generate incidents. Incidents are either false positive or true positive. In one word, false positive basically means that something is flagged as malicious or or deviation by the security software, but it is a normal behavior in the environment. So it's not an actual incident. False positive means it is not an incident. This is a normal behavior. However, your security software is unnecessarily flagging it as malicious because it doesn't have the context behind it. It doesn't know the context. For example, you have a jump host in your environment, a jump host which allows you to remotely access air-gapped network or other applications in your corporate is by default configured to allow management port 3389 or port 22. And these ports are sometimes enabled from internet, enabled from public internet. And any security solution would constitute that as a threat, would constitute that as a misconfiguration. So if you receive such log or such alert from security software, you will close that alert as false positive. So security software is right in its judgment that this is a misconfiguration. This is something which is not usual against the best practices, but it doesn't know the context behind it. It doesn't know that this has been done by purpose. This has been something that has been approved by the security team. That is false positive. What is true positive? True positive means security software is generating an incident, an alert. After you investigate, you also rubber stamp that approach. You also say that, yes, it's a true incident. It's a true alert. That's true positive. So since so many solutions are generating a lot of alerts, it will become very slow and it will result in manual process on part of your analyst to look into those alerts and analyze them. Then comes fragmented visibility. Now, you're not looking into logs from one solution. You're actually looking into logs from multiple solutions. So you need to make sure that you are able to identify those logs. You're able to read those logs. You're able to analyze those logs. You're able to figure out what those logs are, what information they're dealing with. I'm refreshing the browser because I have three SIEM solutions open there. They will sign me out if I do not have any activity on the browser. Okay, so that's what we are talking about. Then comes the additional benefits that it brings on the table, which is compliance pressure. Now, most of the organizations, they need to comply with uh, regulatory standards and compliances such as HIPAA, GDPR, CCPA, DPDP, KSA, PCI DSS, FedRAMP. These are all compliances. So they need to comply with these standards and compliances. And these compliances mandate use of a log monitoring solution. That's first thing. Second, these compliance mandate retention of security logs beyond a certain period of time, probably 6 months, 1 year, or we have a compliance in India for financial institutions put by RBI, which is the governing body, which mandates all all financial entities to maintain a record of customer transactions of the last 10 years. So it differs from country to country. There are data privacy compliances such as California Consumer Privacy Act, Journal Data Protection Regulation for Europe, GDPR. We have personal health personal health information compliance such as HIPAA in North America. We have other data privacy compliance in Middle East, such as KSA in India, which is Digital Personal Data Protection Act. So all of these compliances, they would demand that you need to retain audit logs for a certain period of time, and you need to perform continuous monitoring of security logs. Now, all of these challenges, all of these factors would require an automated solution which can analyze logs, which can store logs, which can provide insights into the environment. That is why we need a SIEM solution, SIEM and SOAR solution. SOAR I will talk about later, but this is what SIEM is all about. This is why we need a SIEM solution. Next. Okay, so what is a SIEM solution? Now, SIEM solution is a combination of SIM and SAN. And when we combine them together, it becomes SIEM. So what is the solution? It's security information management. SIM stands for security information management, which means any security information which is available is being managed by this solution. So what is that security information? That security information is insights into your environment in the form of logs, in the form of telemetry data, in the form of alerts, in the form of events. That's the security information. So this solution is there to manage that security information. So this solution, allows for long-term storage. It allows you to search that data. If required, you can also generate reports for compliance and historical analysis purpose. And then comes security event management. So information management, which is storage, analysis, and then comes event management, which is real-time monitoring of that data, performing correlation if that data is coming from multiple devices. Let's say there is a brute force attack in the environment. Now, what is a brute force attack? It is, if someone tries to forcefully gain access to a system and they are not authorized, it constitutes brute force attack. So when there's a brute force attack, it involves an external IP address. It probably involves a domain. It may involve a bot, or it could be an advanced attack, which is triggered using AI, or which is triggered using robots or bots. So it would involve a couple of information. Now, this information can be analyzed in near real time by a security event management solution. So they can analyze this information across multiple devices that is known as correlation. So when there's a brute force attack triggered from public internet, your firewall will contain the IP address, the incoming trace of that attack. So it will contain the incoming IP address, the port and protocol from where the attack is getting triggered. The system on which that attack is getting triggered will contain the log in terms of location, in terms of timestamp, in terms of how many attempts, how many failure attempts. The application which is monitoring that system will also contain telemetry data about that attack. So there are multiple systems that will provide you insights about that attack, and that is where correlation comes into the picture. So SIEM solution allows you to correlate. You can correlate that data. They can also generate alerts on security events as they occur. SIEM fuses both. It collects data from across the environment, normalizes it into a common format, correlates events to detect threats, and gives analysts one place to investigate and report. That's what SIEM basically does. So this is a detection tool. It detects incidents. What are the core functions of SIEM? Centralized log collection, logs from different sources, from different data sources, which is your desktop, laptop, tablets, mobile phones, switches, routers, VPN devices, web application firewalls, DOS, DDoS solutions, IDS, IPS solutions, they all will be consolidated. Logs from various applications will be consolidated and they will be stored in a log repository. So it's a centralized log repository, and those logs will be stored in, in a formatted manner. In after transforming, those logs will be stored. So logs from endpoints, network, cloud, applications will be stored. Normalization and correlation, wherein it will transform the log. It will transform the raw log into some meaningful information that you will see in the subsequent slide. Real-time alerting. Now, it is not real-time alerting actually. There is nothing in this world as real-time. It is near real-time. So always remember, it is near real time. What is near real time? Near real time basically means that there will always be a lag of a couple of seconds, couple of minutes, or a couple of milliseconds. It cannot be in real time. When SIEM generates an alert, it means that the event has already occurred a couple of seconds ago, a couple of minutes ago, depending on how have you configured the SIEM, how frequently it needs to analyze the data, what is the time interval between which it will pick up the samples. Based on all the configurations, it will generate the alerting. So it is always near real-time alerting, not real-time alerting. Then comes dashboard and reporting. It also provides you with dashboards and reports and compliance reports also, because SIEM also is required from compliance perspective. So you can generate the reports of all the incidents that have occurred of a specific type in the last 6 months, in the last 1 year, and you can submit these reports to auditor when they arrive at your premise for conducting various audits and compliance activities. So that's what a SIEM solution is. Now let's look at a SIEM tool architecture. This architecture is very important for you to understand. So I'm trying to present this architecture, in this infographics mode and in the boxes, which basically shows you various stages or phases of a SIEM solution, SIEM and SOAR. And I will also present you the architecture in the form of infographics. This is a SIEM architecture. So you can see in this architecture, we have multiple phases. We call them phases or stages also. So there are multiple phases and stages. So you have a phase which is data source, ingestion, log storage, log storage, and then analysis, and then dashboard and alerting. And then you also see in the presentation, we have these phases. So let's try and understand these phases from SIEM perspective. This is very important that you understand these phases, and this will constitute the strong foundation when it comes to any SIEM and SOAR solution. And from today onwards, whether you learn CrowdStrike SIEM, NG SIEM, whether you learn Sentinel-1 AI SIEM, whether you learn Microsoft Sentinel SIEM, whether you learn any other SIEM and SOAR solution, the process will remain the same. The fundamentals will remain the same. So let's get started with the first phase, which is data sources. So as I told you, the job of a SIEM solution is to analyze security logs. If it has to analyze security logs, you need to feed security logs into the solution. And in order to feed security logs into the solution, you must have visibility of all the log sources in your environment. You can only protect what is visible to you. This is what Gartner said at one point in time, that visibility is very important. You can't protect what is not visible. So there's a high probability that you have a mission critical application, but you don't have visibility of it. You have some critical confidential data stored in some data repository. It could be on a physical drive. It could be on a virtual storage. It could be in a NAS-SAN. It could be on a cloud storage, and you don't have visibility of it. If you don't have visibility, how will you protect it? So visibility is very important when it comes to security. So for any SIEM solution, visibility is important. It should have logs coming from every system, every device, every application that you would like to analyze, that you would like to include in your log monitoring exercises. So visibility is very important, right? So what are my data sources? What kind of logs I'm ingesting into the SIEM solution? What are my data sources? So my data sources are endpoints. What endpoints? Desktop, laptops. When I say desktop laptops, I'm referring to Microsoft Windows server and client operating system, different distributions of Linux, Android OS, iOS, Chrome OS, or any other operating system that a SIEM solution supports. Because at the end of the day, the job of a SIEM is to analyze logs. So it hardly makes any difference where the logs are coming from. It has nothing to do with compatibility here. As long as you can ingest logs, as long as the solution knows how to analyze those logs, how to interpret those logs, it can provide visibility into any security misconfiguration. So we're talking about logs coming from devices such as endpoints, network. Now, when I say network, I'm talking about firewall logs, web application firewall logs. I'm talking about perimeter firewall logs. I'm talking about intrusion detection system, intrusion prevention system. I'm talking about VPN devices. I'm talking about IDS, IPS. So network devices. It also includes logs coming from switches, router, hub, repeater, gateways, whichever device you want to ingest logs. Then comes cloud. When I say cloud, I'm talking about public, private, and hybrid cloud. So cloud such as Microsoft Azure, activity logs from Microsoft Azure. If it is AWS, we're talking about cloud trail logs. If it is GCP, we talk about cloud audit logs. You will configure all of them into the subsequent exercises. So we're talking about cloud logs. We're talking about SaaS applications, applications which are readily available that you browse, that you access through a web browser. You don't need to deploy and configure them. You just subscribe and you are ready to go. So we're talking about logs from those applications. We're talking about identity logs, Active Directory logs, Microsoft Entra ID logs, identity and access management logs, cloud identity logs from GCP. We're talking about logs coming from identity tools such as Okta, SailPoint, Savient, ForgeRock, CyberArk, Ping. These are all the examples of data sources. So what is my ultimate goal? My ultimate goal is to gain visibility of my environment. So the first stage is data sources. So what we do, we basically ingest logs from different data sources into the SIEM. That's exactly what you see here, that we have endpoints, we have network devices, we have cloud services, we have identity systems, and they all are sending data to SIEM solution. Now, how are they sending data? What are we deploying to have them send data is something that we will talk about when we perform log ingestion, or when we look at various capabilities through which we can perform log ingestion. So we are ingesting logs. We are feeding logs into the system. Now, when we feed logs into the system, how do we feed logs? For feeding logs, we have tools and capabilities. So we have collectors, we have agents, we have forwarders, we have gateways, we have different methods to ingest logs. So we have collectors. Collectors are like a small application, which is an agent, lightweight agent that you deploy on the system. So if you want to ingest logs from a laptop or a desktop or a server, you can deploy the agent that is provided by the SIEM vendor, and the agent will then be configured to collect logs, and it will feed those logs, or it will collect those logs. Uh, if required, it will optimize those logs. It will cache, compress, encrypt those logs, and then it will send those logs to the SIEM solution over a secure channel. So that's collector. Now, in the context of CrowdStrike NG SIEM, we have the notion of collectors. Collectors are devices which are provisioned to collect logs from different data sources. So we have collectors, we have forwarders. Forwarders is the concept that we use in Splunk and QRadar. So these are different tools and capabilities through which you are collecting logs. Now you are either deploying them directly onto the source, onto the data source, or you are putting them in the same network as data source and configuring these collectors to collect data, log data from those data sources. So that's what collectors and forwarders are. That's exactly what they do. Now, then comes the next stage, which is parsing and normalization. So after the logs are collected, these logs are in different format. For example, if I show you the logs, if we go to event viewer, over here, if I click on any of the logs, let's say if I go to security logs, and if I filter for errors, so we don't have any errors right now. Let's clear the filter. Let's look at any of these logs. Let's say, let's filter it for warnings. If we have any warning, okay, we don't see any warning here. Let's see. Okay, over here we see a warning. So this is what we see here. This is the warning. This is a log, and this is how this log looks like. So if I just show this log here, this is how the log will be fed into the solution. So the log could be in different format. It could be a standard format. It could be a non-standard format. It could be in any format. And there are different devices which are ingesting logs. So what is normalization? What is parsing here? So for example, Windows event logs are in this view, XML view. Then there are solutions such as firewall devices. There are solutions such as applications. They're also sending logs. So they're sending logs in different format. It is like we have people from different nationalities and they speak different language. And then there's a listener on the other side. Now that listener is your SIEM solution. So how will SIEM understand who is talking, what they are saying, because they are speaking in different language. So you have interpreter, you have a language converter. There is somebody who will be able to convert that language in the language that the listener understands. So if you're talking in your own regional language, in your own mother tongue, the converter will convert it to a common language, which is, let's say, English. So they will convert it to English because English is a common language that is spoken and understood across the world. That is where parsing and normalization comes into the picture. So what happens in this stage, parsing and normalization, the logs are accepted, then the logs are transformed into a meaningful format, into a standard format. That's what parsing is. Normalization is gaining additional information from those logs. That's what normalization is. So in the subsequent slide, you will see here normalization example, parsing and normalization example. Look at here. This is the log source, raw log source. So the log is like this. July 17th, 9/11/02, FW01, percentage ASA -6 -302 -013 colon built inbound TCP from 203.0.113.9 oblique 51322 to another IP address. This is a raw log. Similarly, you have another raw log, which is event ID equals 4625, user John, status equals failed. So this log, the first log is coming from a firewall. The other log is coming from an operating system or from an application. These are two different types of log, and you can see that they are not in the same standard. The way these logs are written is different. So how do you expect your SIEM solution to understand what they are trying to say? That is where you parse. Basically, you transform this log in a common standard and you store it in such a manner that the SIEM solution will be able to run queries or analyst will be able to run queries. So how are they parsing this log? Now you can see the normalized fields. So in the normalized fields, you can see the event type is network connection. Does it say that it's a network connection? No. This is where the enrichment also happens. It enriches the log. It adds additional context to that data. So if you see an IP address, it can add location context to that IP address. If you see a domain, it can add additional context to that domain. So it shows event type network connection, source IP. You see IP addresses here. It says inbound TCP from. From is source IP. You can see the port also, oblique 51322. It is the port. And then it says the destination IP and destination port, and also the action. Action. Do you see if it says it was allowed or denied here? No, you don't see that. But it was able to parse that yes, the action was allowed. Similarly, over here, I'm sorry. If you look carefully, it says event ID 4625, user John, status failed. So it is after this log is ingested into the solution, the SIEM parser or the SIEM is able to standardize this log. Now it says user is John, action is login, outcome is failed. Over here, it doesn't say that the action is login. So this is what enrichment is all about. So log normalization and parsing is the activity where raw logs are fed into the system. System analyzes the logs, transform them into a standard format so that a common queries can be made on those logs. That's what parsing and normalization is. While this activity is done, the logs are also enriched. Additional context to those logs are also added. And after parsing and normalization, logs are stored into a log repository in the form of events. So they store in the form of events, and those events then can be searched by using query. Every SIEM solution uses a query language. So that's parsing and normalization. Next stage is correlation. What is correlation here? After these logs are ingested into the system, these logs, these logs will then be analyzed, correlated against security monitoring rules configuration. So as a security analyst or SIEM administrator, you have written some behaviors. You've identified some behaviors that if there is any log that points toward a failed logon attempt, and if the number of concurrency is more than 10, if there is any log that points towards successful logon attempts, but those logon attempts happened within half an hour from two different geographical locations which are thousands of miles away from each other. If there is any log that points towards any movement from one system to another, if there is any log that points towards the attempt to encrypt the data by a ransomware. So your security monitoring team has written some logic. That logic will be analyzed here, which is security monitoring rules. So these logs will be analyzed by the rules, and if these logs contain, if these log matches the condition of the rule, then the incident or alert will be generated. So you will have some out of the box rule which are written. You will have some rules which you will write manually based on your security monitoring requirements. UEBA stands for User Entity and Behavior Analytics. This is a capability of machine learning wherein you will collect data from different you will basically collect data about your user behavior across a specific duration, let's say for the last 2 weeks, last 3 weeks, and based on that behavior, based on when user logs in, when user access a specific application, whether user is able to successfully access, based on all those behaviors, it will generate pattern. If it identifies a deviation from pattern, it will be quick to generate an alert. For example, you have a user who is your network administrator who works from Monday to Friday and who works in regular shift timing. At 2 o'clock midnight on Sunday, you receive an attempt from that user to log into a database. Now it's a deviation in behavior. How come a network engineer at 2 o'clock in the morning on Sunday trying to access a database? This is not a normal behavior. This is a deviation. So this UEBA will be quick to generate an alert. It will generate an alert that this could constitute a security incident. It could be an identity compromise. It could be identity impersonation. Somebody, some threat actor, some hacker probably has compromised the user identity and they are trying to access critical database for the purpose of stealing data or for the purpose of gaining access to the system. So that's correlation engine, which is also based on machine learning detections. Then comes storage and indexing. Now, what is storage and indexing? As I said, these logs are stored. So when you store logs over a period of time, you will have a lot of logs. You will have logs in not in KBs and MBs. You will have logs in GBs, terabytes, petabytes, and they directly impact the cost of storage, which could go significantly higher after a certain period of time. And you can't delete those logs because they are required for compliance purposes. Auditors will ask you for logs when they arrive at your premises for performing audit. They will ask you for the last 1 year of log. So how will you provide those logs? That is where we store and index the log. So we have different types of storage here, wherein we store current logs from last 30 days, last 60 days, last 90 days that you would need for correlation and pattern creation. You will store them into hot tier. Basically, they are readily available. Logs that you will need to analyze once in a while performing some correlation, you will store them in warm tier. And the logs that you don't need to analyze every now and then, probably logs which are older than 90 days, you will store them into cold tier or archive tier. So these are different tiers in which logs are stored. Then comes in the end, which is dashboards and report. So if I navigate to my SIEM solutions that I have opened here, over here you see the dashboards. For example, this is the dashboard of Microsoft Sentinel. It's a SIEM solution. It's a cloud native SIEM solution from Microsoft, which is accessible from Microsoft Azure portal. This is also accessible from Microsoft Defender or Microsoft Security portal. So over here, you see the dashboard. The dashboard shows number of incidents in the last 24 hours, automation, any SOAR automation that has run, the data that you have collected in the last 24 hours, current status of the solution, security monitoring use cases. This is known as dashboard. Similarly, you see a dashboard in Singularity Operations Center also, which is another type of SIEM and SOAR solution from Sentinel-1. Over here, you also see a dashboard. So this dashboard also shows you certain results. Since I have not configured anything in these solutions, you are not looking at all the data, right? So I will probably go to the maximum we can see is last 7 days. So in the last 7 days, you can see we are looking at information in terms of how many incidents have been generated, how many log data sources they require attention, log volume by sources, how are we receiving logs, how much log data is being received on a specific day or on a specific week over a period of time. All that information you see here in the dashboard. Similarly, you see dashboard for Falcon also. Unfortunately, they signed me out. Let me quickly sign back in. Okay. So I'm signed into CrowdStrike Falcon dashboard also. Here you also see a dashboard. So you see this dashboard, which basically shows you total number of incidents, new detections, total events that it has analyzed, data sources, most recent detections, detections by tactics. You see a lot of detections here. This is the dashboard. Similarly, for NG you also have a dashboard here, which basically shows you the detections or shows you the current status of your SIEM solution configuration in the form of dashboard. So this dashboard is getting generated from the data from the logs which are getting collected. Based on those logs, we are generating these dashboards. So that is where the last stage is dashboarding and alerts. So over here, you see dashboards. Those dashboard shows you alerts. Those dashboard shows you incidents. Those dashboard shows you detections. Now, these terminology differ from one solution to another. For example, in the world of Falcon, we call them detections. In the world of Sentinel-1, we call them alerts. In the world of Microsoft, we call them incidents. They are one and the same thing. Something that needs to be looked into, something that needs attention of security professionals. So we use these terminologies interchangeably from one solution to another. Okay, so let's move on. So this is about your SIEM architecture. This is how a SIEM solution is configured. So once again, let's do a quick recap. So it all starts with ingestion of log, ingestion of data from different sources. The solution has the capability to read those logs and analyze them, transform them into a meaningful information, store them, generate security events and alerts whenever there is a deviation from standard operations, also store those logs for compliance purpose and provide dashboards and reporting. That's how a SIEM solution is architected. I'll take a pause here and see if any participant has a question. Okay, let's move on. Now let's get into the detail of all these stages that I've just talked about, that what are those stages and how it all happens. So when it comes to data ingestion methods, as I talked about, that data ingestion methods We have different types of data ingestion options available. The first option that you will find in use at most of the organizations is Syslog. Now, what is Syslog here? When you need to collect log data from networking devices, such as switches, firewall, router, web application firewall, IDS, IPS, we basically deploy a Syslog server or a Syslog tool. We configure that tool to accept data from those devices, and then we configure the tool to export, stream, or send that data to your SIEM solution. So that's Syslog server. So we basically collect standard TCP UDP protocol based logs from firewall routers and servers. Now servers also include Linux systems. You can also, instead of deploying an agent on Linux servers, you can basically configure Linux to send logs to a Syslog server, and then Syslog can forward those logs to your SIEM solution over a secure channel, which is 443. So the logs are encrypted, they're received at SIEM and then decrypted. So that's one method of log ingestion. Then there is another method, which is agents. As I talked about, you deploy agents locally on the log data source, configure that agent to collect logs and send those logs to SIEM solution. Forwarders and collectors, they could be sitting locally on the log data source, or they could be deployed in the same network as log data source so that they can collect the logs. And they also have the capability to sometimes and transform the logs, filter the logs, redact uh, any PII or any confidential information from those logs, hide that information, filter the logs. If the log contains empty fields, empty values, they will filter the logs. So these collectors, forwarders, agents also have these capabilities. Then comes API and webhook. API basically means you can have cloud integrations, direct integrations, wherein you can send logs through API also. Instead of deploying a collector, for example, an application, you cannot install anything on the application. In itself, it's a binary code. So if you want to collect logs from an application, you can directly configure API-based injection or webhook-based ingestion, wherein you will either pull the logs from application or application will push the logs to SIEM solution with SaaS platform and security tools. Then comes file-based logs collection. You can also collect logs from FTP servers, SFTP servers, or any file share about the activities which are happening. You can collect logs from databases. So this is another method of collecting logs. You can directly configure JDBC, ODBC queries against an application to ingest logs to a SIEM solution. And then you also have cloud native connectors. Cloud native connectors basically means these are out of the box connectors which are available to integrate a specific cloud service provider's log or a specific application from that cloud service provider to ingest into your SIEM solution. For example, if I navigate to Microsoft Sentinel, if I navigate to content management under Content Hub, so they have moved Microsoft Sentinel to Defender portal. That is the reason every time you try to access Microsoft Sentinel from Azure portal, it will ask you to basically navigate to Defender portal. So while this is, okay, this has loaded. Okay, over here, you see Content Hub. These are out of the box solutions which are made available by any SIEM solution. So over here, you see a connector for AWS. You will also see something for Google Cloud. If I type Google here and search, you will see something for Google also. So you can see Google Apigee, Google Directory. So this is the connector through which you can ingest Google Workspace or Cloud Identity Log. This is the connector through which you can ingest Google Kubernetes Engine log. So you have a couple of out-of-the-box integrations or connectors available. These are known as cloud native connectors. By using these connectors, you can directly configure ingestion from your cloud service providers, and you can define what kind of data you want to ingest into the SIEM solution. Same is the case with Sentinel-1. In Sentinel-1, if you navigate to policies and settings, over here you see this AI SIEM. So this is the Sentinel-1 AI SIEM configurations. Over here, you can also configure connectors. So you see this cloud account, AWS, Microsoft Azure, Google Cloud. You can just click on these and you can configure the connection. So it says connect AWS account. You just need to follow the instructions on the subsequent screen and you will be able to ingest logs from AWS, and you will also be able to decide what kind of logs you want to ingest. So you will be able to ingest logs from AWS or from Microsoft Azure or from GCP into Sentinel-1 AI SIEM. Same is the case with CrowdStrike. In CrowdStrike, when you navigate to NG SIEM, under NG SIEM, you have all of these options, which is case management, detections, log management, dashboards, data onboarding. Over here, you will see a lot of connectors which are available. You can configure these connectors. These are out of the box connectors or ingestion methods which are available, using which you can either pull logs from those data sources or you can push logs from those data sources to your NG SIEM solutions. You can see the connectors. This is a connector for Okta, which is an identity and access management solution. There is a connector for Microsoft. So you will see a lot of connectors. I'm saying this list is endless. You can see the connector type here, push pull connectors, and you can ingest more connectors. You can click on add connection, and you will see we have a total of 201 connectors available, and they are across AWS, Azure, GCP, different applications. And this list is dynamic. As we move along in this training, you will see that NG SIEM or CrowdStrike will continue to add more and more capability. So they are trying to optimize end user experience. They are not expecting you to write parsers. They are not expecting you to write data connectors from scratch. They will provide all of those connectors as out of the box capability so that with a few clicks, you will be able to configure it. So this is known as data ingestion methods. So we have agents, forwarder, collectors, webhook, cloud native connectors, database queries. These are different ingestion methods through which you are receiving data. Okay, next, log parsing and normalization. I've already explained this. Let me be quick on this slide. So we just talked about that we receive raw logs. These logs are unstructured text that arrives from sources, from different data sources, unstructured in different formats. These formats they are different formats. So the job of a SIEM solution, or the job of the job of a parser is to receive that log, read that log. If required, it will filter, it will remove any empty entries into the log, because log contains key value pair, it contains information. So remove all unwanted information that is not needed and only read the information which is needed, and then transform it into a standard format. What is that standard format? That standard format could be CEF, which stands for Common Event Framework. It could be SIM, which Splunk uses. CEF is used by ArcSight, QRadar, and then ECS, which Elastic Security uses. Or there are other formats also, which is known as OCSM, which is cross-border, which is for multiple solutions to work with each other. So what is happening here? They are receiving raw logs. They're parsing the raw logs. They're extracting fields from those raw logs, and those fields are then written in key value pair. So key is source IP, value is the IP address. So they're written in key value pair, and they are normalized. If there is any additional information that needs to be extracted from that log, which is enrichment, that is extracted just like action is allowed. And after that, these logs are stored into the log repository. That's what parsing and normalization is. So as part of this training, we are going to look into log parsers. If required, we'll create a custom parser to ingest logs from a solution that does not provide out-of-the-box connector. Okay, so after parsing, you will need to store data. So how are you storing data? We have different types of tiers: hot tier, warm tier, cold tier, archive tier. What kind of data are we storing in hot tier? We are storing the data which is active data, the data that is getting ingested from log data sources. And we are storing the data here for up to 30 days. Now, this differs from organization to organization. I'm not saying that you only put hot data in, for 30 days. You only put current data for 30 days in hot tier and then move it to some other low cost storage tier. That differs from organization to organization. But most of the enterprises, most of the businesses or customers, they tier log data across, they store log data across tiers. So any data which is current data, they store it into hot and warm. Any data which is historical, they put it into cold and archive tier so that they can comply to standards and compliances. So you can see here, hot data, 0 to 30 days, relative cost is highest because you're putting that data into the main storage. It is like standard storage. If you're aware of the storage services of cloud, then in Microsoft Azure, in the container, you have standard tier. Then you have, so you have hot tier, then you have cold tier, then you have archive tier. In AWS, you have S3 standard, S3 infrequent access, S3 Glacier, or S3 Glacier flexible retrieval, Glacier deep Glacier. There are different types of storage tiers. In Google Cloud also, you have standard, nearline, cold line, and archive. So these are different types of storage tiers. So you can see here, anything that is a current 0 to 30 days, put it into the old tier, 30 to 90 days warm tier, 3 months to 12 months cold tier, and anything which is older, historical, put it into the archive tier. So you're putting them into the archive tier. Now, how are you accessing these logs? If they are in hot tier, they have milliseconds of latency, which means you need it, you have it. If they are into warm tier, it may probably take a couple of seconds for those logs to be available to analyze. If they are into cold tier, it may take a couple of minutes. And if they are into archive tier, you will need to request access to those logs, which may take from a couple of minutes to a couple of hours. Then only they would be available for analysis. That's what archive tier is all about. So what are we using hot tier for? Day-to-day SOC operations, which is active investigation, live dashboards, day-to-day SOC operations. What are we looking warm tier for? When we are performing, when we are working on a problem. So we have incident problem. Problem is multiple incidents of the similar nature that are occurring day after day. So you convert that into a problem and then you try to resolve it. While trying to resolve it, you need to get into the history. You need to get into some other details. So that is where you basically put that into warm tier. Cold tier, we basically use it for threat hunting. You want to hunt for threats. You want to look for the logs of last 90 days to do a pattern analysis, to do some correlation. You will use cold tier. And archive tier is compliance and legal hold. So these are different types of tier which are there. If you want to see this in the SIEM solutions, let's see in Microsoft Sentinel. In Microsoft Sentinel, if you want to see this information, we basically go to under configuration, we navigate to settings. So guys, I actually have good expertise on 5 SIEM and SOAR solutions that I've been using for the last couple of years. And I have also been delivering training and consulting sessions on them. 3 you see right in front of you. 2 solutions, I don't have access to their console because these are expensive solutions and you cannot just purchase each and every solution just because you want to deliver training or you want to show some correlation. So these are the 3 solutions that I have licensed. I can grant you access to these solutions as and when you need. So over here, you can see the storage tier. So you can see these are the storage tiers that we have log ingestion 50 GB per day, 100 GB per day. And when we basically, and if you want to configure that for how long you want to store a specific log, you basically navigate. So in the context of Microsoft Sentinel, the log storage is known as log analytics workspace. So there is a log analytics workspace, which is basically attached or onboarded into Sentinel. Sentinel is the analysis engine and workspace is the log repository. So over here, if I go to the workspace, I can see the retention part. I can see that what all logs I'm retaining. So in the world of Sentinel, logs are stored. The normalized and parsed logs are stored in the tables. And here you see the retention for the tables. So by default, you can see that the tables are the retention is configured for 30 days. But if you see that there are some logs that I want to retain for a longer duration, what I can do, I can basically click on these three dots. I can click on manage table, and over here I can configure the retention. So over here you can see the default retention for this tier is table is 30 days. Total retention is 30 days. Now I can configure the retention. So I can configure it for, let's say, 90 days. So you can see that analytics retention is 30 days. And then the additional that you have increased 90 days, it will be in the long-term retention tier. So what will happen for 30 days, the data will be available in hot tier. You can, and this tool can analyze the data in near real time. And after 30 days, it will be moved into the long-term retention tier. There, Microsoft will charge you less. That's how the tiering is. So that will help you to save significant amount of money. The same concept, if you want to do, if you want to see in Sentinel-1, in Sentinel-1, you basically navigate here, and here you see log collection rule data ingestion. So here you basically configure the ingestion tier. Now, in some security solutions, SIEM solutions, ingestion tier and retention is configured at the tool level. So it is configured at the tool level, and the billing is based on what you have agreed with the OEM, with the solution provider. Similarly, over here in NG SIEM also, if you want to see that information, you will see that information here under data settings, when you can see the retention part also. So you can see different types of log repository where data is getting stored, and you can see the retention also. For some of them, it's 90 days. For some of them, it's 365 days. For some of them, it's 7 days. So if you want to change any of these retentions, you can connect with your CrowdStrike technical account manager, and you can discuss and conclude on the cost, and accordingly you can have them changed. So this is the retention part, which is very important for a SIEM and SOAR solution. Then comes the query language. So let's say we have ingested log data into the solution. The logs are parsed, logs are normalized, and they are stored into the storage tier, different storage tier. Now we need to analyze those logs. So are we analyzing those logs manually? No, we are not analyzing those logs manually. The logs are analyzed by the solution on a regular time interval. Some analysis you will create, some analysis it will do by itself. So in order to analyze the logs, they basically query the logs. They write a query. That query is executed against the logs, and then it will populate the outcome. The outcome in terms of whether there is a match. If there is a match, then the incident will be generated. If there is no match, then it will just move on, and the query will rerun after next interval. That's how it happens. So we have different query languages. You can see in order to learn query language, so Splunk basically uses SPL, which stands for Splunk Processing Language. Microsoft Sentinel uses KQL, which is known as Custo Query Language. Elastic Security uses DSL or ESQL, which is Elastic Security Query Language. Google SecOps, which is again a niche solution in the market. You have very limited professionals or handful of professionals who know Google SecOps, which is another solution that I also deliver trainings on, which uses YARA-L. This is a rule-based language that was created by threat hunting professionals or threat professionals or incident professionals to to basically analyze malwares. So this is a malware analysis language that has been converted by Google to analyze logs. And then IBM QRadar uses AQL, which is aerial query language. So these are the query language. Now, all of these query language, they have their own format, their own schema in which they are written. The most common query language, if you want to know, are KQL and SPL, because majority of the query language follow the same syntax. So SPL is Splunk, a search processing language. We also call it Splunk processing language, but this is search processing language. And KQL, this is pipe-based Unix-like chaining, and KQL is tabular because it runs on a, because the log data is stored into a relational database into tables, which contains rows and columns. So you run this query against those tables. which contains rows and columns, or which contains column in the form of fields, and then rows that contains the value of those fields. So it's a SQL flavored. So if you're coming from a database background, Microsoft SQL database background, you will not find difficult to learn this language. Now here you see an example of these language for the same use case. So my use case is that I want to analyze the logs and I want to find if there has been any failed logon attempt on any system. So we all know that when it comes to failed logon attempt, and if it's a Windows system, whether it's a client or server, it writes those failed logon attempt in an event, and the event for that failed logon attempt is 4625. So if the event ID equals 4625, it means it's a failed logon attempt. So in the KQL, how do I write it? In the KQL, I will first write the table name. So the table name is security event, which contains logs. Or if you want to see it in Microsoft Sentinel, you basically navigate to over here, logs. And here you basically write KQL. So here it says query history, KQL mode. Here you write the KQL. So you basically write it starts with table name. You write the table name. For example, these are the tables. Heartbeat is a table. And then even if you type the table name and hit enter, it will show you the content of that table. It will show you all that is written in that table. Since I don't have any log sources configured in Microsoft Sentinel, because the billing is based on the amount of logs that you are ingested and how frequently those logs are analyzed by Sentinel. So I'm just showing you from demo perspective that yes, this is how it is done in Microsoft Sentinel. So you write the table name. Similarly, you will have a table name security alert and you will hit enter. You can write additional information or you can just write the table name and it will show you the logs from that table. All the logs which are there in that table. Same is the case with S1. In S1, if you want to write, and if you want to write logs, you basically need to go to its Singularity Data Lake, and in the Singularity Data Lake, you basically look into the logs. So you navigate to Data Lake and then you do it. Then comes the CrowdStrike. In CrowdStrike, if you want to do it, you basically navigate to Next-Gen SIEM, and over here you see this log management event search. So over here you navigate and you search for events. So the logs are parsed and normalized, and they are written into this event. So you see event search here. You can run queries. Here it will give you some UI, and if you want to run the search, you can also run an advanced event search. Here you can type CrowdStrike query language, and that query language will search for events that you are looking for. So here you type so here you see all the logs. These are all the logs that has been ingested into CrowdStrike from different data sources. If you want to search for anything, these are the fields. You can select the fields and you can type the query here. Right? So that's how we run the query. So let's look at here. So if you want to search for failed logon attempts in Microsoft Sentinel, you will type the name of the table, then you will type where event ID equals to 4625, and then you will summarize. Summarize in the sense what result you want to see. Number of counts of 4625, user against which 4625 is there. You can hit in the summarize column, you can add additional fields and it will populate the data. If you want to write the same query in Splunk, the Splunk basically use the concept of index. So whatever logs you ingest into Splunk, it is stored into indexes. There are different indexes that it creates. So you basically pick up that index, which is security index, because security index will contain these logs. And in that security index, you select the source type as Windows event log, and then you type the event code as 4625, and you find status by user. So it will show you number of users and the number of times the failed logon attempt happened on those users. That's Splunk. If you want to do same thing in CrowdStrike query language, you basically use the same concept wherein you are storing logs into the tables, and those tables you're writing it. So over here you can see the table that contains the log is security event, and then you are filtering for 4625 failed logon attempts, and you're typing that, okay, I want failed logon attempts. And while it populates the result, you want to see the username, the computer name, the username, who initiated, for whom the failed logon attempt was executed, the system on which the failed logon attempt was reported, logon type, whether it was interactive, and then it will sort the failed logon attempts and it will show it into the table. So this is the query language, which is very important. So what we are going to do as part of this training, we are going to learn CrowdStrike query language. So I will talk about the syntax, that how do you write query language from scratch. We will try and build on that knowledge step by step, and we will see what we can cover in the limited time that we have. And I will also share a collection of CQL, common CQL of common security monitoring use cases, which are across a SIEM and SOAR solution and the corresponding CQL for that. For example, failed logon attempt, this is one CQL. So I have a collection of 100 plus CQLs that you can directly configure in CrowdStrike in your production environment that will cover majority of the security monitoring use cases across a device, across a variety of various log data or log sources. So that's query language. Okay, so after the query is written, what is the next step? The query will generate result. The query will either return no result, which means the behavior is not existing in the environment, which is a good news that your environment is protected, or the query will generate a result. And that result will show you the impact, severity. I'm saying you just type this query, failed logon attempt, and you see 100 lines of results. You see multiple users and multiple failed logon attempts, which is a bad thing. This is where you need to investigate. This is where a SOC analyst comes into the picture. So what are those techniques? How are we generating those results? So these are detection and correlation techniques. So what are these techniques? These techniques are these SIEM solutions, they have their own method of detecting incidents. So what they are doing, for example, in Microsoft Sentinel, if you navigate to analytics, this is where you basically write the query. You basically create the analytics query. So what Microsoft Sentinel has, it has its own analytics queries, out of the box analytics queries that it will run over a period of time. And then you will also write your own. So you can see active rules templates. So you can see these templates, machine learning behavior, threat intel. So Microsoft Sentinel has out of the box analytics rule that it will run over a period of time to perform any correlation or analysis of any deviation. Similarly, Sentinel-1 has its own analytics rule, which is known as star custom rules. So you basically have star custom rules that you basically write here, which is here. Custom data tables, configure, parsers, custom log ingestion, custom log sources, log collection rules. So over here, you basically write the rules. Basis on those rules, you're able to get the information. Similarly, in CrowdStrike query language, you also have the option of creating CrowdStrike query language and then generating and then basically creating a security monitoring use case from it. So these are different options which are there. That's exactly what is written here, rule-based correlation. So you will write a security monitoring rule, and the rule will say that this is the logic. If there is a match to this logic, do this, which is if this is then the logic across multiple events like failed logon attempt, new admin rule. Threshold and time window rules, you will provide some additional alerts or rules, which is if the amount of logs ingested suddenly increase, if there is a sudden increase in the amount of logs which are getting ingested, or if there is any deletion activity that happens into the environment, if there is any configuration changes that happens to a specific log data source. For example, an S3 bucket in Amazon in AWS, its access setting has been changed from private to public. It has been made public. So it's a configuration change alert. So any time window rules, it will also include user and entity behavior, which is Based on the logs that it continues to receive, it will identify the identities, and against those identities, it will create baseline for normal behavior, which is, let's say, uh, this employee is working from this, in this shift, this employee has this level of roles and permissions, and this employee is responsible to deal with these applications and systems. If there is any deviation from it, it will be quick to pick up that behavior and generate it. That's what it basically does here. Then comes threat intelligence matching. So it does threat intelligence matching also from time to time, which is cross-reference events, bad IP addresses, hashes, and domains. So any SIEM solution will receive threat intelligence feed from different sources, and those threat intelligence feeds will tell SIEM solution that these are the blacklisted IP addresses. These are the known file hashes which have been reported or which has been flagged by different security solutions. These are the known bad domains, URLs and domains. So the SIEM solution, based on those threat intel feed, it will quickly run the rule-based correlation out of the box rule correlation, and it will identify if there is any presence of that IP address, that domain, or that file hash in my environment. That's what it does. Then comes machine learning anomaly. What is machine learning anomaly? The out-of-the-box correlation rule, which it basically runs and identifies. MITRE attack mapping. All of these security solutions, most of these, I would say, they basically have mapping with MITRE attack or attack IQ framework, wherein they show an incident, an alert, a detection mapping to MITRE. So if you see that in CrowdStrike, it is all the detections that you see, you will see that there is a mapping with MITRE attack framework there. So if I navigate to endpoint security, if I go to detections, all the detections, when you look at those detections, they will show you tactics, techniques, and procedure and how they map against MITRE framework. So you can see here, tactics and techniques, custom intelligence for this. And if when you go into the details view, you will see MITRE mapping for this also. So it shows you that how this maps with how this detection is mapping with MITRE. So you can say tactics and techniques. It's a custom intelligence indicator, which is part of indicators of compromise from where this detection is generated. So probably Man Singh created an indicator of compromise configuration where Man Singh blocked the file hash of Wireshark. And when he tried to execute it manually, the CrowdStrike was quick to look into the IOC, identify that the file hash matches with the entry in the IOC. It blocked that operation. So that's what it basically says. Okay. So that's the attack mapping, which is a common behavior for most of the SIEM and SOAR. Then comes common SIEM security monitoring use cases. These are the common use cases that you will see in most of the solutions. So what are these common use cases? Over here, you can see brute force and credential attack. Most of the organizations would monitor for any failed logon attempt or any forced entry into the system. Lateral movement, when there is a malicious payload, any worm, virus, malware, ransomware, it will try to authenticate, it will try to move from one system to another to corrupt all the systems. Data exfiltration, any attempt to steal data, any attempt from any malicious payload, spyware, or keylogger to upload data to a remote system or to a cloud storage, it will monitor. Insider threat, any employee who is performing an action which is not expected out of him or her. That's insider threat. Malware and C2 weakening, the same concept, the presence of any malware and an attempt to connect to its command and control infrastructure or command and control server to seek instructions or to execute instructions. Compliance reporting, which is another use case for SIEM monitoring. If you want to ingest logs, store them, normalize them for compliance and historical analysis perspective, that's what you do. So these are the SIEM monitoring use cases, or these are the use cases that would require you to have a SIEM and SOAR solution. You cannot monitor brute force attack using an EDR. That's not possible. Why? Because EDR comes into the picture after you logged into the system. Brute force attack happens when you are trying to log into the system. So an EDR cannot identify a brute force attack. So these are some of the use cases. The additional use cases could be suspicious PowerShell activity, cloud misconfiguration, privilege escalation. There could be a number of use cases. So I have a list of 300 plus security monitoring use cases for any SIEM and SOAR solution that I have collated over a period of time that I will be sharing it with you guys.